Welcome everyone. In this video, we are going to prove that cosine of alpha plus beta is equal to cosine of alpha times cosine of beta minus sine of alpha times sine of beta. To carry out this proof, we will use a very nice geometric picture that we will base our calculations on. So let me draw the picture for you. We will have a triangle, and not just a triangle, a right one. You know, triangles are never ever wrong, but they are sometimes right. So this is a right triangle, and I want to call this angle alpha. Then I will draw another right triangle like this. This angle is the 90 degrees angle, and this guy is called beta. I will call this length L, and to make the picture more clear, I will complete the frame. I will complete this picture to a rectangle in such a manner. Alright? And I could have even, let's not have dashed lines. Let's have a solid line. So I complete this picture to a rectangle. And this is touching it here. So you now have enough information to be able to carry out this proof. So if you want, you can stop the video now and then try to do this on your own. And when you're ready, continue. Alright, I assume you're back, and let's get started then. First, I want to consider how we could get cosine of alpha plus beta in this picture. Notice this. We have what is looking like a Z shape here. Right, don't we? Because this side and this side, they are parallel. We have a rectangle. We completed the picture to a rectangle. And if they are parallel, we have a Z shape, which means this angle is going to be alpha plus beta. Okay, you can prove this using basic symmetry or the angles of a triangle, that sort of thing. But I guess you are familiar with this. But if this doesn't make sense to you, please write that in the comment section, and I will prove this in a future video. So we got this. And now if I consider this triangle, the one that is in orange right now, then I can say the hypotenuse is L, and if I look on this side, starting here and ending here, it is going to be, let's color code it, it is going to be the hypotenuse, which is L, times cosine, because this is the adjacent side to our alpha plus beta angle. We have cosine of alpha plus beta. So right away, cosine of alpha plus beta, the quantity that we are trying to find a formula for, appears in our picture. Cool. Now I want to continue with finding formulas for other lengths in terms of given quantities. Let's color code it like this. This blue one will be L times the cosine of beta, because this is the adjacent side to our angle beta. And if I consider this right side, then I will have L cosine of beta, this is the hypotenuse, times cosine of alpha, because the side that we are interested in is the adjacent side. Now I want to consider this side, and this side is going to be, again we have the hypotenuse L, times, this time it is the opposite sign, so we put sine of, it is the opposite side I meant, so we put sine of beta. And here notice one thing. Since the interior angles of a triangle add up to 180 degrees, this angle here is 90 degrees minus alpha. And since this is a whole angle, when we are adding the angles on a line, it should add up to 180 degrees. If we have, I should erase this, we don't need this picture. If we have 90 here, 90 minus alpha there, then the other one, the remaining third angle, should be alpha. So this angle here is alpha. And this is very useful because now we get to express this side as well. That side is going to be the hypotenuse, which is L sine of beta times, since it is the opposite side, we put sine of alpha. And look at this. From the picture, we can see the top and the left sides should be equal to one another because this is a rectangle. And that means when we add this orange one and this green one, we should get the red one. So why don't we do that? Let's do that. We have, I am writing the red first, we have L cosine of beta times cosine of alpha. This is equal to, now I am going to write the addition, which is L cosine of alpha plus beta plus L sine beta sine alpha. Here L's cancel. Great, because it was really arbitrary. We didn't care about L and we see that it cancels. Hooray. So L is gone. And now if I solve this equation for cosine of alpha plus beta, let's see what I get. So I will subtract this term, which is sine of beta times sine of alpha from both sides, and that will leave us with cosine of alpha plus beta on one side. On the other, we will have cosine of, we had beta times alpha, so let's rearrange it to have cosine of alpha, cosine of beta, minus sine of alpha. Oh no, it didn't, there's not enough space. I'm talking like Ferma right now. So we have cosine of alpha, cosine of beta, minus, I am subtracting the term that we subtracted from both sides, sine of alpha, sine of beta. And would you look at that? This is the exact same formula that we said we would prove at the beginning of this video. I am aware that this is a hard proof to come up with if you are not given the picture. But if you are given the picture, I think it is very doable. But in the case that you are wondering, I wouldn't be able to think of this because I need to admit, I wouldn't be able to think of this. Okay, I saw this on another source and then I carried out on my own and saw that I could get the answer. But without having the picture, it is really hard to come up with it. So there is another way of proving that cosine of alpha plus beta can be represented in such a way. That is a more straightforward and standard way of proving this statement, and you can access that derivation from the cards right now, also from the descriptions part. And if you like this visual proof very much, then I have another video about this where I prove using the same picture sine of alpha plus beta. I proved that formula as well, and you can access that from the cards right now, also from the descriptions part. Anyways, I hope this video was helpful. If you have any questions, please add them in the comment section. I hope to see you in another video. Until then, take care.